Okay, let's rock and roll. On to our next little point. When we're talking about translations or any kind of transformations, you might see something called replacement notation or mapping notation. This becomes really, really crucial. So what's the difference? So let's talk about replacement notation first. Replacement, you've kind of heard that word before. It's very, very similar to the word substitution. Case in point, let's look. What if I gave you an equation, y equals to 2x plus 5, and I told you that x equals to 3. Well, you know and I know through the years that you've been in math that you can take that 3 and substitute it in right there. This will give you 2 times 3 plus 5. You go ahead and use BEDMAS. 2 times 3 is 6 plus 5. This works out to be 11. But isn't it interesting that you took this 3 and you replaced x with 3? See what I mean? You could either use the word substitution or replacement. Aha! So if I replace this x with 3, don't I still get the same thing again? Of course I do. Now, we're going to step this up a little bit. We're going to use this idea of replacements or substitution, okay, with functions. Aha! So take a look. Here's our function. I want to talk about x. So in other words, if I'm talking about x, I'm talking about horizontal translations, or we're going to refer to them as HTs sometimes. You might see it written down as HT. I'll use the full words, but HT I put into my notes because it's just easier to type HT than horizontal translation. And plus it saves ink, right? All right. So we're going to take this x and we're going to substitute, or better yet, replace the x with x minus h. Now, check out the notation. This says take an x. See the arrow? Arrow says replace with x minus h. So what does this mean? Okay, there's the x in the function, and I'm just going to replace that x right here with x minus h. And look what I got. Bang, right there. Y equals to f of x minus h. And this, of course, being that it's inside here, being that it's beside the x, means a horizontal translation. Aha! Well, does the same thing work with the y's? Well, of course it does. I'm going to replace the y now with y minus k. And there's the notation for it. Take the y, replace it with y minus k. Now, being that it's a y, you know and I know this is going to be a vertical translation. Okay, vertical translation. So watch what happens. Take this y, what was y, make it a y minus k. So I'm going to put it back in the original function. I'm going to replace that y with y minus k, and that's what it's going to look like. Now, I know you guys. I know you people, right? Think about it. I know you want to resort back to Math 20-1. And you want to take that k and move it over. Yeah, you know what? Go right ahead. That's totally up to you. But for now on, I like to use this notation here. I might interchange back and forth here, but this is actually the preferred notation in Math 30-1. So I'm going to try to use that as often as I can. So look what happens. Let's take a look at the general idea here. The general idea is this. If you have the original function, which is y equals to f of x, okay? So y equals to some sort of function of x. Look what I'm going to do. I'm going to say, okay, I'm going to go and say that h here is positive. If h is positive, remember h goes with the x's, that moves to the right. So I'm going to take this h, I'm going to put it in here, right here, and I'm going to say my h is positive. Remember, the notation has a negative built in. This is where people mess up, because they're going to take that positive h, we're going to put it in here, but they see the negative sign and go, oh, it's going to move left. No, it doesn't. The original notation has the negative built in, so just put it in here like that. Consequently, look at this. Look at this. Or conversely, look at this. Look, you got h is less than 0, which means h in this case is a negative. right? So if h was a negative, look what happens. You take the h and we're going to substitute it in here. Watch what happens. This becomes f of x minus a minus h, which becomes x plus h. So when h is negative, this guy eventually becomes a positive. And that's because of this negative idea. Same thing happens to the k values. Look, if I take this and I do the k values now, if k is positive, it means that this is going to go upwards. Look what happens. This becomes y minus a positive k and x minus h. This value stays the same as what you see written right here. Boom. Right here. Look, stays the same. But if k is a negative, which means that it moves downwards, look what happens again. That means this k, which is no longer positive, it is now negative. You get a negative value, making this a positive. Watch out for this. This playing around with the signs like this tends to really mess people up. So take a few minutes right now, just put this podcast on pause and refresh your mind over this again and again and again. It's similar to what you learned in Math 20-1, because if you think about it, what you learned in Math 20-1 was this stuff. But now we're applying it also to the vertical movements here. So take a few seconds right now, pause the podcast, or rewind this and watch it a second time to make sure that you've got it, okay? Because we're moving on to the next part. Ready? Here we go. So, what does this mean? Replacement notation versus mapping notation. This is the second notation that we're going to look at. It's called mapping notation. Do not confuse mapping notation for replacement notation. Because remember, replacement means to replace or substitute. Okay? So, take a look right here. If you look at this particular thing, it says, let's look at an example. Let's say here's y equals f of x. We're going to translate this. We're going to move it 3 units to the right, 2 units up. Now, let's think about this for a second. If we look at the original equation, which was y minus k equals to f of x minus h, right? And you know that h refers to the x values. That's why we put them close together, which means a horizontal movement. The k we put with the y's, which mean a vertical movement. So x is the horizontal movement. So I'm going right 3. So in fact, this is h equals to 3. This 2 is a vertical movement. I'm going up 2, so that refers to our k value here. So since I'm going up, k is in fact plus 2. So plus 3 and plus 2. Look what happens when I substitute those in. Let's put the h value plus 3 in. Right here, this becomes f of x minus 3. Do you notice? Do you see the minus? The minus is there because the original formula has a negative in it. Similarly, if you look at here, there's a plus 2. The plus 2 will go in for the k value. So this is y minus a plus 2, which means that this is y minus 2 equals to f of x minus, let me clean this up a little bit, f of x minus 3. But both of them, even though they appear negative in the formula, are actually positive movements. That's why it's so important to identify the h and the k before you go out and do anything. All right, so let's get back to replacement notation. So if you think about this, look what I did. Look what I did. I took this original y and replaced it with y minus 2. See? So I took the original y, I replaced it with y minus 2, and look what I've got. Boom, boom, boom. I took the original x, replaced this right here with x minus 3, and look what I got. But remember, because this is a formula, or this is the actual function, because it's the actual function, remember that the h is actually a positive value, the k is actually a positive value. So important to remember that. Okay, so what I'm doing with replacements, replacement notation usually deals with the entire function. Now, what does this h and k thing mean? This h means that every x value is going to be moved, right, 3. Every y value is going to be moved up 2. So that's what mapping notation will tell you. Check this out. When you're dealing with mapping notation, you're dealing with a point. You're dealing with the point. So when a mapping notation says, look, here's the original point, x, y, tell me how does it change? So the point changes, every x is increased by 3. Right there, baby. That's why this is a plus 3. Every y, then, is increased by plus 2. That's why every y is increased by plus 2. So the mapping notation deals with the points. The replacement notation deals with the actual function. Do you see the difference? Look at the difference between these two. This has a y minus 2 because it's in the equation. This has a y plus 2 because it's the mapping. This tells you this is what the equation looks like. This is what the point's going to look like. Oh, let me throw one more thing at you. Remember, this one's really, really, really important. Mapping notation looks like this. Don't get it confused. This does not mean this, right? You're not taking this guy, you're not saying, oh, take the x and replace it with x plus 3. No, 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 don't. What you should do is you should say, okay, this is the x value. That's got to be the h, which equals to 3. This is the y value, which means that this is the k, which is equal to 2, right? This is wrong. That is wrong. You do not take the replacement value. What you do is you go, okay, with that, I'm going to look at the original equation, which is y minus k equals to f of x minus h, and I'm going to put in the h value being 3, the k value being 2. There's my formula for the function, but what was the mapping? The mapping was x minus y becomes every individual x is increased by 3, every individual y is increased by 2. The mapping says that the x is replaced by, oh, look at the formula. X was replaced by x minus 3. Y was replaced by, look at the formula. Y was replaced by y minus 2. Oops, minus 2. Right? You see the difference between the two. This is crucial. So don't confuse mapping, which looks like that, with the actual function, which looks like this. Two separate things. This is the point. This is the function. Keep them separate.